Hello, everyone, and welcome to the second round of Fan Request Roulette here on Answer Everywhere. I believe I'm live. Sorry about yesterday. I thought I was live. OBS told me I was live, but YouTube seems to not think that I'm live. There might be a change either in the version of OBS I have or YouTube where I have to jump through extra hoops, but I think I'm live now. I think I have the right chat open. And let me just verify that that YouTube thinks the right stream is open.
Yesterday,
okay. Whoa. That's not what I want. Okay. Cool. Very cool. So for Fan Request Roulette, if you didn't see the previous one, we're going to pick a random fan request. I've gotten a bunch of fan requests. All of them are awesome. We have about 42 now. And I figured the way to fairly go through them, rather than making sure that everyone who requests something later feels like we'll never get to their thing, is to do a kind of lottery. And so we've got our super secure and super advanced random number generator, which is we're going to take the Bitcoin price. Whoa now. And we're going to concatenate it with the latest Taylor Swift tweet, minus the emoji, because I don't know how Python or the shell will handle that. And that'll be our message. And then we're going to hash it. Let's see. We'll do SHA-512. And then we get a list. We'll just pop this into our spreadsheet. All right. And now we'll sort by the seed. And that'll give us the top 20. And then to choose among the top 20, we're going to roll a d20. All right. So I think I've sorted blanks. Let me undo that and get rid of the overflow here. All right, cool. So here's the top 20, just so we can see in ordering. And then I've got this concept of boosts and anti-boosts. And so what we're going to do is everything that's a multi-request, we're going to take the top. Hi, this bird has been charged. How's it going? Some of these are your requests, I believe. So some of these are are multi-requests. This is where a user's requested a bunch of things, and they're all great. But we're just going to take the first one, which is randomly chosen each week, which one is first, and then we're going to remove everything that's a multi-request from the same user. So we'll get rid of these other LC requests that are in the top 20. And then these two are multi-requests with, I guess I'll not count this since domesticated sloth also suggested the same thing. And this bird has been charged. Only has, I guess, one in the top 20, so I don't need to worry about that. And then I want to make sure the early adopters, who are kind of the first two requests that I've got, always make it in the top 20. And they're just going to bump the lowest non-early adopter, I guess. Which I think is... First of all, let's clear this, because now this is not giving us good information since I deleted things. So we should be 21 rows down, right? I think maybe Metasploit just doesn't make the cut for today. Where's my early adopter here? Antler. What have I done wrong here? Let's try this one more time. All right. And then just sanity check our ordering. Okay, let's see. What did I kick off? I thought I had kicked off Metasploit, but Metasploit's there. But it would have been there anyway, right? I think I kicked off the right thing, despite having made an error in how I did it. So that's the top 20. The stuff that didn't make the top 20 this time are, I have a request for data-intensive applications. I have a sense of what that's going to be, probably some of the Apache projects, or one of the Apache projects. Wicked Engine, glibc, GNOME or KDE, and Emacs flow, where I looked at Emacs before, but this was a request to kind of look at how the C code hands off to the Lisp code and walk through a debugger. OBS, Monero, Grub, OpenFOAM, GNU Mock or GNU Herd. Those are GNU Mock is the microkernel, and then GNU Herd is the kind of, I guess, services around the microkernel. X or Wayland, a tutorial on how I go about reading code, a proof assistant, either Leancock or Agda, gedit, HTTP or HTTPS, SQLite or SQLite, Antler 4, NFS, Rabbit or 0MQ. Quake we already did, so we can get rid of. Xterm or another emulator. And the stuff that did make it in, you can see, I guess, at the top. What's early adopter? Early adopter are folks who were like subscribed and asked for things a little way before before everyone else. Essentially, before the TCP video blew up. So you know, it was a smaller crowd then, and I don't want them to feel like left out. You know, after things exploded because I didn't get to their video in time. 189. What's 189? Okay, yeah, sure, tutorial. Yeah, I'd love to do that. That actually sounds fun. All right, so let's roll a d20. Summer, I have a browser. All right. All right, and it is 12. And 12 is libssh2 or OpenSSH. All right. I don't really know what libssh2 is, so I think I'm going to go with OpenSSH. Let's take a look. I assume it's on GitHub, or at least the mirror of it is. OpenSSH portable. Is that what I want? I'm certain Wikipedia must have an entry, and they usually have the GitHub. Yeah, OpenSSH portable. Okay. Let's go ahead and clone this so we have a local copy. All right, thank you, Python. It's not quite what I meant to do, but that's okay. All right. So we have the code downloaded. I guess we should create tags just for fun. All right. And what else do we want to do? I have source graph open in the background. I don't know if source graph cares, I don't know if it does any optimization in the background, but I'm going to try passing in the repo and doing a test search just in case that kicks off any sort of processing. Well, we've got a repository match. Okay, cool. All right, so OpenSSH, I'm going to assume folks here know what the deal with SSH is. It's the secure shell. It lets you get a shell on a remote machine. Then you can just do all of your bash or ZSH or whatever your preferred shell is. You can do all of your shell stuff. after authenticating and encrypting, as opposed to, say, Telnet. Have you gotten access to Cody? Cody's. I've been able to use Cody so far. I think this is Cody, right? Assuming this is what I'm. Where did Cody go? This is Code Intelligence. Cody. Oh no, Cody is. I don't know. What was I using before? I thought that was Cody. Maybe he wasn't supposed to be using Cody. But the source graph people reached out to me, and I think they said that they could give me some tokens or whatever they're called, which would be cool. All right, cool. So I don't have access to it right now, but it's SSH. So for this particular repo, both Bard and ChatGPT should know basically everything the internet knows about SSH. And I guess let's look at the Wikipedia entry, just in case it has info that I don't happen to know that's relevant. Yeah. So my understanding is that before SSH, which is before SSH was way before my time, but that people did things like Telnet into the remote servers without proper authentication. And that the idea of OpenSSH is you have, just like we used to do internet without HTTPS, and TLS is kind of a secure tunnel through which to send your messages, that OpenSSH is basically the same sort of thing for something like Telnet. So OpenSSH suite includes the following utilities: SCP, which is a secure copy for RCP. I don't know RCP, but I use SCP all the time to copy files securely between machines. SFTP, which I didn't realize was part of OpenSSH, but a secure replacement for FTP. SSH, a replacement for RLogin, and RSH, which I also don't really know, but Telnet I was familiar with. I guess the difference is that Telnet maybe doesn't let you authenticate as a user, like through the login prompt, the way that one of these two did. Probably RLogin did that. I'm not sure. Then SSH-add and ssh-agent. These are these hold your keys. So you will sometimes have to run into a situation where you're trying to SSH into some box, and you have to add the key manually through SSH add or whatever. And then keygen, which is used for generating keys. Keyscan, which scans a list of hosts and collects their public keys, which I was unaware of. And SSHD, which is the server daemon that you have to be running to accept SSH logins. Okay, so for this, I'm going to ignore SFTP and SCP. I think I really only want to look at SSH, although we may need to know some stuff about the agent about the agent and add in order to really understand how SSH operates. Keygen I will ignore, and then keyscan I'll ignore because I didn't know about it. Cyberduck. So this bird has been charged, said, love SCP, but have to Google it every time. Cyberduck nowadays. I don't know what Cyberduck is. Let's look up Cyberduck. An open source client for FTP, SFTP, WebDAV, and cloud storage. Okay. With a bookmark manager. So this is like an FTP server or client, right? I think the beauty of secure copy is that you don't have to have, I mean, you have to have the SSH server running, but you don't have to like have a FTP server configured or anything. All right, and what is SSH keyscan? It doesn't exist. Well, then why is there a link? Why is there a link to it? I guess that's why the link is red. Okay. Oh, vulnerabilities. Before version 5.2, it was possible for an attacker to recover up to 14 bits of plaintext with a success probability of 2 to the negative 14. That seems like pretty relatively easy. up to 14 bits. I guess you can't get more than that. Or can you do it multiple times to get more bits? It's related to the CBC encryption mode. Well, you don't want to use CBC encryption mode. The AES counter mode and ARC4 ciphers are not vulnerable to the stack. Okay. CBC is the one with the it like reveals the structure of things, right? No, I don't know, but let's look it up. CyberDuck is legit. So Electra Pantera is apparently also a CyberDuck fan. All right, I'll look into CyberDuck for my my lifestyle. I don't maybe I'm thinking of ECB mode. I hadn't heard of it. Is it just FTP or does it do like extra stuff that people think is cool? Okay, so CBC is I think better than ECB, but not as good as the other thing whose name I'm now forgetting. Okay. All right, so let's look at SSH. This should all be written in C, yeah, and some Roth and some shell and some makefile stuff. Okay. And when did it go back to? Was it 99? Is that what it said? Initial release 1999. Okay. Get rid of this thing. All right, so we have M4, which is like macro preprocessor type stuff. OpenBSD compat, which we can totally ignore. Regress, which might be interesting from a security point of view, but I'm going to ignore it. And then I guess the C files are in the main directory. And there are lots of them. And since there's so many files in a single directory, I guess I might use Emacs. Unless Cody wants to tell me something. I think I've decided that I don't have access to Cody anymore right now. Is that right? Okay. All right, let's try it. Cool. All right. So these are obviously in alphabetical order. I guess I'll add the maybe what I want is this. I kind of want to know how big these files are. Let's try ncdu. So just ignoring directories, the tags file is big, which is that's a moduli, which might be related to moduli for encryption. Then the biggest files are things like the configure, which is not so interesting. ed25519, which is going to be an elliptic curve implementation, which is interesting, but maybe not. Won't tell us so much about OpenSSH per se. Then channels, which is probably important. Let's open channels. Keygen, readconf, serveconf. These are like configure support. SSH key. I guess we want to know about SSH keys. Probably just essentially some struct with that includes, you know, some pointer to the private key and or the public key. Client loop. We want client loop for sure. In fact, if there's a server loop, we want that too. Session. All right, what else? What are we looking at? We are looking. I misnamed my directory here. Let's actually do this. We're looking at OpenSSH is the answer to your question. Oh, and you know what? Now that you mentioned this, I should change the title of my stream here. All right. Synac. All right. This bird has changed. What do you? What is this joke about hunger? Oh, I missed a bunch of stuff. Okay, for your last question, this bird has been charged. It says it connects to everything. I have my S3 folder. Okay, DigitalOcean, Droplets, Dropbox, another FTP server. Oh, okay, yeah. So I guess if you're administering a lot of, I guess a lot of site administration stuff uses FTP, right, to move assets around. That makes a lot of sense. And then I guess it has some sort of S3 support. Yeah, Google Drive really. Yeah, Google Drive is good. I forget what the Google version of S3 is. The buckets, whatever those buckets are called. Oh, Synac snack. I see. That's a good pun. Okay. And then ssh.c we definitely want. What's going on? What? Okay, ssh.c. Session.c, I think we already grabbed sshd. .c. SSH connect. That might be important. What do we think? Connect. Connect to. Let's look at all the connect, I guess. And then ssh.1. I don't know what that is. KRL. Key something or other. Auth PAM. Okay. I think that'll be good for now. Thanks, NCDU. And then let's add some auth stuff. Maybe auth 2. And then we have a bunch of different auth options like host-based, pub key file, password, none. Let's look at auth.c. Auth FD, maybe file descriptor, auth file, auth.h, that's probably the header. Then a bunch of Cypher stuff. Let's look at Cypher AES and Cypher.c. We've got cha-cha support, which is interesting. Cleanup, I don't know if that's interesting. Compat, I'm going to guess is not interesting. DH should be diffie-hellman, I guess. Let's look at that. DNS. I didn't know OpenSSH needed its own DNS support. Fix algorithms and fix path. Maybe let's look at fix algorithms. Hash, HMAC. I'm not sure. I'm just not sure what, how important the crypto stuff actually is for understanding SSH. And then match and Mac. Message is probably vital, as is Mux. My proposal. H. What is that? Packet. I guess we probably want packet. Platform. I think we'll ignore platform. Poly should be an algorithm. Poly 1305. I don't remember what kind of algorithm that is. Progress meter. We can ignore. A bunch of protocol stuff. I guess I'll read the protocol just to see what it is. Read pass. Rindall should be the Rindall cipher. But I thought that was AES. How do you spell Rindall? Maybe like that. Yeah. Its original name was Rindall. Blob store, big store. The equivalent to S3 is blob or big store. Maybe blob store? Cloud storage buckets, I think is it just called cloud storage? Google GCS? I think it's just cloud storage is what I'm thinking of. All right. And then here's SCP. It's, I guess, just one file, similar to SFTP. And then here's agent and API. I think we want kind of all of these. And you know what? I'll mark scp.c. Do we get an scp.h? All right, fair enough. Might as well at least mark one of the keys. PKCS11, I will not look at, just out of protest. If you've ever dealt with PKCS11, I don't think I've ever met anyone who's dealt with it who enjoyed it. And then they've got some malloc stuff. I guess that's not so surprising. And some stuff with whatever XMSS is. See if we can find out what XMS is. XMSS. Cross something? Is it a hash-based signature thing? So I said Google Cloud Storage was the thing that I thought was equivalent to S3. I'm not. I've never used S3 really, so I'm not positive that that's the equivalent offering. I'm just saying that's the thing that I was thinking of. I don't actually know. So blob store. You could now. Oh, okay. Yeah, it sounds like I think cloud storage is the replacement for blob store. So Samir Khan. Oh, hi, Samir. I forgot that was you. So you're an ex-Googler, so you know what you're talking about. Blob store might also be the internal name. I think something like that's going on. Okay, but I don't really remember, honestly. I don't think I ever really used it either. Okay, so we've got lots of stuff marked. I don't know. I don't have a real strategy. I guess let's go through. Can I just limit it to things that are marked? Yeah, we're on naming Thomas. Yeah, Thomas Kurian was a is, I guess, still he's like cloud CEO. Let me just try occur with an asterisk. All right, that's pretty good. Oop, the other one. Samir says he won't speak ill of those not in the room. Yeah, when I was there, Thomas Kurian was I guess a somewhat controversial figure. I don't know anything about what's going on now. Okay. So, like, how do we want to start? I think, oh yeah, I wanted to look up one thing, which is that, let's see. So like for Emacs, I'd like to know, so go related file. So see the header. This was a feature that I used all the time in Google. FF find other file. All right, well, let's try that. Okay. Okay, I guess let's start with, first of all, let's figure out what's ssh .1 is, or .l. File no longer exists. Is that because I marked everything in the, in the wrong directory? Uh-oh. Let's see. So, at the risk of, let's do this again. Will it take me there now? All right. So I don't know what this ending is, but this is some sort of weird file. We've got like this .op. Everything's 2 letters. And it looks kind of like a table. Op, FL, LR address. Okay. And then we've got some sort of text thing. And is this .l? Or is it a 1? I think it's a L, right? It's a 1. Okay. I don't know. It seems to be some sort of, I'm going to guess it's something for building. I'm going to ignore all the, what? Where am I? How do I unmark? Oh, I'm in God mode, right? Okay. All right. So let's start with ssh2.header. So we've got this reference to RFC 4251, which is Transport Layer Protocol, I guess. Let's verify what this is. Oh, it's the secure shell. Okay. No, wait, what? Is that what it is? 4251? Yeah, okay. So, this is the RFC for the secure shell protocol. I don't know what which came first, the RFC or this implementation. The RFC is copyrighted in 2006. So I guess OpenSSH came first. All right. I didn't even know there was an RFC wiki. This is kind of cool. Okay. So we've got a bunch of defines for things like message types, transport min, transport max. I'm guessing those are min and max sizes. And they're set to 1 and 49, respectively. Okay. Then we have an user auth min, user auth max, per method min and max, and a bunch of, it says ranges here. These are, I guess, a bunch of ranges for how large things can be. And we have a transport layer generic, which includes things like disconnect, ignore, unimplemented, debug, service request, service accept, and ext info. And then for algorithm negotiation, we have kex init and new keys. Kex must be key exchange, which means we should open it. At least mark it. Okay. And then and new keys. And then this key exchange specific messages. So we've got these kex dh, which must be diffie-hellman init and diffie-hellman reply. I guess we only need 2 for diffie-hellman. No, it should be, maybe reply is used for all replies. DH group exchange. I don't know anything about the group support. And then we have some ECDH stuff, user authentication, etc. Okay, channel related messages. So let's figure out what's going on with channels. We can open it. We can send an open confirmation, which I guess is kind of like an ACK, an open failure. A window adjust, which is, I assume, a request to adjust the window. And we've got channel data. Maybe this is a generic message, or maybe it's like data about the channel, like metadata. Then we have extended data, end of file, close, request, success, and failure. All right. Python X security says, how do you feel by reading the source code for the app? Is that your work? And what's your goal reading this apps? How do you, okay. How do you, so I read fell as feel. Is that what you mean? How do I feel about it? And what is my goal? That's a good question. Let me read a little bit more of this, and then I'll get back to you. So this is this stuff about disconnecting reasons. So I guess if you get a disconnect, you're going to get some sort of message about why you were rejected. And one is that the host is not allowed to connect. There could be a protocol error. The key exchange can failed. Host authentication failed. MAC error, compression error, etc. Service is not available. Protocol version not supported. Host key is not verifiable. Connection is lost. Disconnect by application. I'm not sure what that means, but too many connections. Auth canceled by user. No more auth methods available. So I guess you're going to iterate through some auth method list. And if you fail them all, then you get that error or illegal username. I guess it's got characters that it can't use. And then this is called. And then we have this miscellaneous, administratively prohibited. I guess like it violates policy of the particular thing you're trying to SSH into. Connect failed, unknown channel type, extended data, standard error, and some certificate stuff. Okay, so these are, so ssh2.h, the header, we just have things about, essentially defines messages that in another world, like at Google, this would be like some protobuf, probably. So Python X security had asked me about things like, is that your work, and what's the goal of reading these apps? No, it's not like my job. What's my goal? My goal for kind of doing this tour of open source apps, I think is one, I just think it's fun to kind of figure out how things work. And the other is to encourage others to like look inside of the open source stuff that they use, and just spread the word about cool open source projects, and I suppose to highlight the fact that for most things in the world, you don't really have access to their internal workings. Like for electronic stuff, for example, you can take them apart. For physics, we have some equations of physics, which you can write down. But open source software is one of these things that is a thread throughout everybody's lives, whether they know it or not. And it's something that you can peek inside of and get a sense of how it works. And in fact, you can figure out exactly how it works because it's written in code. So I just think that's interesting. And what I've noticed is I tend to read code more than most people, I think. So I just wanted to, like share the idea that this is something that people can do to get a better appreciation for that part of the world. Yeah. Okay. So let's see if find f, what is it? FF find related. I guess ssh2.c doesn't exist. Okay. All right. So where's my dir red buffer? Okay. So SSH2 is not so important. Let's take a look at maybe session or server loop. Let's look at server loop. We have only one function, which is server loop. And we can go to its implementation. And in the implementation, we have other functions as well. I guess let's look at what else we have. We do a bunch of includes that are not in the header file, including things like key exchange and cipher and host file. All right. And then we have server options, which is externally defined, and a bunch of other external stuff like auth context. Bind permitted, sig child handler, client alive check. I guess it's just maybe a heartbeat to tell if the client is still alive. Send a bogus global channel request with won't reply. You should get back a failure. I guess that's kind of like a heartbeat. Keep alive at OpenSSH.com. Wait, what? I guess that's a That's kind of funny that, that there's this particular email address that I guess the SSH knows that if they see that, then they'll send an error back. Is that what it says? Get back a failure. Okay. I guess the reason you get an error back is that this particular email address, OpenSSH.com, has committed to never using for legitimate OpenSSH purposes. And then Python Access Security is asking, do I code review for apps? If yes, do I find bugs? Oh, do I do code review for apps? I do when I was at Google, or when so right now I'm building a thing that's not publicly known right now. And right now I'm the only one working on that. So not currently, I don't, but yeah, like at Google, I do everyone does code review. And yeah, you find bugs. And like, I don't think I'm digging deep enough here to find bugs in most of the stuff that I'm looking at. And I'm actually not looking for bugs. So I haven't found any, like, on this particular journey that I've been on with Answer Everywhere. Typically, if you're doing code review, it's like a much smaller amount of code, like a diff or a commit, and that's an easier scope with which to find things like bugs. We've got this wait thing, which is going to sleep in peephole. Okay, and then let's go to the server loop here. Server loop 2. I don't know what happened to server loop 1. We've got collect children, which has an interesting name. So let's just look what it does. It's going to take an SSH struct, which I don't think we've seen. And we're going to create a PID and a status. And we'll check if the child is terminated. And if so, we are going to loop, waiting for the PID do something. Maybe emit w no hang. And then if the PID is -1 and the error number is enter, which I'm not sure what those things mean, then, oh, no. Wait, what? Oh, this is all part of the same guard for the while loop. And then if we enter the while loop, we'll check if PID is bigger than 0, and if so, we'll close by PID. Otherwise, we'll set child terminated to 0. Okay. I'm not sure what that does because I don't know enough about PIDs and when they are 0, or what the SIGs and error numbers really mean, but that's fine. So here's server loop. I'm guessing this is the main server loop that the server does. It has an SSH struct. It also takes an auth context. And something about polling. npfd, something file descriptor. And a bunch of ints. connection in ready, connection out ready. Those actually seem like bools. And then we have uints, unsigned ints for connection in and connection out. And we've got some sig set, probably signature set, B sig set and O sig set. B, I'm not sure. O, I'm not sure. And so what do we do? First, we're going to check if the sig sets are empty, or if we can't. The other part of this, so sig sets empty, I'm going to guess, is what this means, because I don't know the return value of that function. This, I'm going to guess, is some sort of failure to add the signature set. And then if either of those happen, we're going to error out saying that the B sig set failed. And if we don't fail, we're going to send some sort of SSH signal with sig child, maybe send it to the child process with the sig child handler. Let's look up SSH signal. We get no comment. We do find related. There's still no comment. Okay. So we're going to send some sort of signal, mask other signals. We've got this memset thing. We've got some handler, which, what is SA here? SA is sig action. The sig action is going to give a handler, and sig fill set, I guess we're going to fill the memory. And then we're going to check if it's sig alarm. And if so, we'll set the flags to restart. And otherwise, we'll check if sig action, sig num SA, and OSA is equal to -1, in which case we'll return a sig error. Otherwise, we're just going to return the handler. Okay, so the handler is what we get back. But here, we're ignoring the return value. And what is sig child? Is this a general Linux thing? What does it do? Is it CHLD? CHLD, not child. Okay. So this is, I guess, part of Linux rather than SSH. Sig action. Examine and change a signal action. Okay. Let's see what Stack Overflow has to say. It has to find all the possible outputs of this question. Okay. When you fork a child process from a parent process, the sig child is set, but the handler function is not executed. After the child exits, it trips the sig child, and thus causes the code in the handler function to execute. Okay. So this sig child means like kick off, I guess, execution of a child. And what is the child here? I'm not sure. Where did we get sig child handler? It comes from somewhere, like the ambient environment, I guess. At any rate, we're going to send a signal to the child, I guess, telling it to start doing child stuff. And we'll set child terminated to 0, I guess, because we just kicked off a child. And then connection in and connection out are set by calling SSH packet get connection on the object. So the object, I guess, contains references to the connections, possibly to some sort of socket object. We'll check if we're going to use privsep, like privilege separation. And if so, or if we're not using privilege separation, we're going to send sig term from the sig term handler, and then send sig int and sig quit. Sig term should terminate. Sig int, I'm not sure. Let's look up sig int. Old Sega 8 yeah, 8 space tabs. Yeah, you're right. These are pretty wide tabs. SIGINT, oh yeah, it's an intelligence derived from electronic signals and systems used by foreign targets. Yeah, that's certainly one definition of SIGINT. But isn't it also a Linux thing? All right. Blogs are not being helpful. Let me see if I can find a table. Linux. All right. Let's ask Bard. Yeah. Okay. So that's the control C. It's used to interrupt a process. The default action is to terminate the process. Okay. So sig term. So we're sending sig term and then sig int and then sig quit to the sig term handler. I'm not sure why. It seems like we really want to quit the sig term handler or whatever the sig term handler is doing, whatever it's handling. And then we're going to call server init dispatch. So this is the main loop. So I guess this is startup. So this is, I guess, killing whatever was running before possibly. And then we're going to say we're going to init. And then we've got a for : : so some infinite loop. I'm not sure why for : : rather than like while true. I don't know if that's just stylistic. Oh, Samir is saying the whole C Spartan programming model has its benefits and drawbacks. Yeah. And then the sig int and term are for interrupts and terminations. They're separate signals because they get handled by different parts of the dependencies underneath. Okay. Underneath meaning going down from user space. Okay, that makes sense. Thanks, Samir. Do you know why they're sending all three? Is that a common pattern? Or does it just mean like really try hard to quit or something? Or is it like int is interrupt, right? What is term? Did you just tell me that? Terminations. Sig term is used to terminate a process. Okay, so it seems like we're saying terminate and then interrupt and then quit. I'll ask. I don't think Bard understands code, but I'll ask ChatGPT. All right. Yeah, I figured. Oh, it's registering signal handlers. Oh, okay. Oh, but you don't know what it's doing, ChatGPT, because you don't know what this function actually does, SSH signal. But I think that's right. Oh, okay. That makes so much more sense. It's not sending the signal. It's registering handlers. And we're only doing it if we don't use privilege separation, because I guess privilege separation tells us to use maybe different handlers for these signals. And that's what I'm going to assume. All right. Thanks, ChatGPT and Bard and Samir. All right. Okay. So here's the infinite loop that I assume is going to be the infinite loop that runs the whole program. And then after it executes, this looks like cleanup to me. So we're going to collect the children. We're going to free whatever PFD is, something file descriptor probably. And then we're going to free all the channels. Free all channels. No more reads and writes. And then we'll free the remaining sessions, e.g. destroy W temp entries. Okay, so this for loop is where we want to be. And what we're going to do in the loop is we're going to process buffered input packets on SSH, and we don't know what that does because this seems to be a void function, or we're ignoring its return value. We'll check if the SSH packet is rekeying, and the packet, SSH packet, not very much data to write. And if that's happening, we'll call channel output poll. So we're going to poll the channel, I guess. Then we get this code comment. It says, block sig child while we check for dead children. Then pass the old signal mask through to peephole so that it will wake up immediately if a child exits after we've called wait PID. Okay, so I'm going to assume that that's the correct description of what these blocks are doing. This is checking for sig term. If we get sig term, we're going to log, I guess, exiting on signal sig term, presumably. And we're going to clean up sig proc mask. This is some check that might cause an error. And wait until we can do something is, I guess, the thing that blocks sig child while we check for dead children. Then pass the old signal mask through peephole. All right. So the first thing we do is collect children, and then we wait until we can do something. And the wait function is going to take the SSH struct, the in and out connection information, some PFID, an NPFID, alloc, NPFID active, then the OSIG set, and then I guess the ready states of the in and out. All right. And if we get down here, we're going to call child after poll. Is P poll? PFD? And then after calling channel after poll, which again seems to just be executed for its side effects, we're going to call if the connection is ready and process input is less than 0, we're going to break, I guess, go to the top of the loop. The process input is again going to do processing. And then a timeout may have triggered a rekeying. So we might need a rekey. And we'll check if the output is ready, in which case we process output. So process input, and then process output down here. And that's the end of the big loop. Okay. So what does that mean? Well, we've got a bunch of functions which we don't know what they're doing, such as process buffered input packets and wait until we can do something. I'm going to guess wait until we can do something is not so important, but process input and process output are probably important. So let's look at those. I think I wanted to look up something else. Yeah, okay. So I want to know, and Sammy, or you might know this, or someone else on here might know this, but I want to know what peephole is actually doing under the hood. Is it people? Okay, so people is going to wait for some event on a file descriptor. It's similar to select. It waits for one of a set of file descriptors to become ready to perform I/O. The set of file descriptors to be monitored is specified in the FDS argument. Okay. So people D has a file descriptor and some events, which are requested events and return events. The caller should specify the number of items in the FDs array in NFDs. So I guess number of FDs. It says FDs array. Oh, so FDS is an array of structures that have, so there's a bunch of these poll FDs, and NFDs is number of FDs. The field FD contains a file descriptor for an open file. If this field is negative, then the corresponding events field is ignored, and the R events field returns a 0. Field events is an input parameter, a bit mask specifying the events the application is interested in for the file descriptor FD. If this field is specified as 0, then all events are ignored, and other stuff returns 0. The field R events is an output parameter, filled by the kernel with the events that actually occurred. The bits formed in R events can include any of those specified in events, or one of the values, poll error, poll hang up, I guess, or poll and val. Cool, that's useful. Select poll is a way to do async on Unix. But we're not, I assume we're not busy waiting, right? No. So ChatGPT says, no, the people function does not busy wait. It is designed to avoid busy waiting and provide a more efficient way of waiting for events on file descriptors. Okay. That's consistent with Sam Ura saying it's for doing async. Okay. When a program calls people, it blocks until one of the specified file descriptors is ready for I/O, or until the specified timeout expires. While the program is waiting, it is not actively using CPU resources. I feel like I might have looked this up before. It is not busy waiting. Instead, the kernel puts the program to sleep and wakes it up when one of the specified events occurs. Okay. Cool. So why do we look that up? We're going to block sig_child while we check for dead children. Okay. And then pass the old signal mask through to peephole. The old signal mask. I don't know what old means in this context, so that will wake up immediately if a child exits after we've called wait PID. I'm not really sure what it's doing with the children. Maybe the children are the shells that it's managing. I'm not sure. But let's look at, let's see, process buffered input packets, which is called SSH dispatch run fatal with dispatch non-block and null. What does this do? Dispatch run fatal takes SSH and mode and a volatile about whether we're done, which calls SSH dispatch run and checks that it's non-zero. And if it is not zero, we're going to call SSH packet fatal. Okay, what does dispatch run do? We've got another infinite loop. And we're going to check the mode. If the mode is dispatch block, then we're going to SSH packet read sequenar, I guess, blocking packet read. This is a single packet. I'm not sure. Otherwise, we're going to call packet read poll. And we're going to look at the type and whether it's less than dispatch max. So if the mode is one of these two things we've returned, there's nothing to do here. If we're here, we're doing something with dispatch, which might include skipping packets, I guess. Where are my line numbers? What? This is not my usual Emacs config, so sometimes I forget that I don't have certain things enabled. Okay, I'm not sure what this dispatch is. I'm going to basically ignore it. But if we go into this else block, then we're going to do some SSH packet disconnect. And if we're done, then we're going to return 0. Okay, let's look at this read packet sequence thing. Waits until the packet has been received and returns its type. Note that no other data is processed until this returns. This function should not be used during the interactive session. Okay, so maybe this is just for setup. And so we got a type and a sequenr. I still don't know what a sequenr is supposed to be. But we get the state from here. Somewhere we should have like a socket, right? SSH packet write wait. Since we are blocking, ensure that all written packets have been sent. Okay, so we're going to send before we block. And then we're going to have this internet loop here. And then we're going to call packet read poll. Does this actually read a packet? It might call packet read poll too. Somewhere a packet must be read, right? Yeah, instead of doing this, let's grep for sockets. We've got netcat under regress, channels. Maybe channels is the place to be. We're including system socket. Okay. But where, so we have the struct channels. We do things with it, but I don't know if we have any socks. Auth socket. Okay, let's look at this channel struct. We have channel context. Okay, SSH channels maybe? An SSH channel struct has channels. Channels alloc, the size of the channel array, etc., and some permissions. Okay, so let's look at this. I'm seeing some stuff in chat. NR is probably sequence number. Thanks, Samir. I guess sure for TCP. I think we saw in one of the headers that it's using TCP, which would make sense. Maybe SSH2.h. Oh no, that just says transport layer. And then, okay, Samir's saying that you tell the kernel to monitor a set of file descriptors, sockets, and poll is kind of slow, though, so network I/O intense binaries tend to use epoll. Okay. I don't know why SSH is using poll. Maybe it just hasn't been updated. Whoops. What is transport for? It's been assigned TCP port 22, UDP port 22. I guess, can you do both? Oh, it's at the, oh, okay. It's in the transport layer. Is that right? Okay. Maybe we can see a description of the packets. Okay. It is a layer architecture with 3 separate components. The transport layer typically uses the transmission control protocol, TCP. Okay, so we are using TCP, reserving port number 22. This layer handles initial key exchange, as well as server authentication, and sets up encryption, compression, and integrity verification. It exposes to the upper layer an interface for sending and receiving plaintext packets with a size of 32,768 bytes each, but more can be allowed by each implementation. The transport layer also arranges for key re-exchange, usually after 1 gigabyte of data has been transferred, or after 1 hour has passed, whichever occurs first. I didn't realize that it did periodic key re-exchanges. That's kind of cool. Then the user authentication layer handles client authentication and provides a suite of authentication algorithms. Authentication is client-driven. When one is prompted for a password, it may be the SSH client prompting, not the server. Okay. Then the connection layer defines the concept of channels, channel requests, and global requests. I'm not sure what a global request is, which define the SSH service provided. A single SSH connection can be multiplexed into multiple logical channels simultaneously. Okay, so your single connection might be multiplexed over multiple channels, each transferring data bidirectionally. Channel requests are used to relay out-of-band channel-specific data, such as the change size of a terminal window or the exit code of a server-side process. Additionally, each channel performs its own flow control using the receive window size. The SSH client requests a server-side port to be forwarded using a global request. Standard Channel types include shell for terminal shells, SFTP and exec requests, direct TCP IP for client to server forwarded connections, and forwarded TCP IP for server to client forwarded connections. And then whatever this SHFP DNS record provides the public host key fingerprint in order to aid in verifying the authenticity of the host. Okay, so that's really interesting. I didn't know a bunch of this, such as this channel, mainly the connection stuff. So you can have multiple channels, and they can be multiplexed over channels. And I guess a global request is maybe one out of band of any channel or something like that. And then the shell is only one type of connection, but we can also, I guess, forwarding TCP over SSH is a different type of channel, I think is what it's saying. And then I'm going to ask ChatGPT. I'll say, tell me about the relative merits of ePOL versus PPOL. And while it's thinking, let me take a look at whatever I was looking at over here. Okay, so here's this SSH channel struct, which is the master structure for channel state. And we've got channel ** channels, which is a pointer to an array containing all allocated channels. The array is dynamically extended as needed. Okay? And then channels alloc is the size of the channel array. Channels pre and post are called just before IO to add any bits relevant to the channel. So these are I'm not sure, like hook entry points, basically. Before and after IO. TCP forwarding has some local perms and remote perms, which are permission sets. Saved X11 local client display. I didn't realize that X11 appears directly in the SSH channel struct. It's kind of interesting. Does Wayland get an appearance? I'm not sure. It seems tightly coupled to X11, which I guess is okay. And then we have IPv4 or 6, and then some channel timeout stuff. But what that doesn't tell us is what a channel actually is. So channels, type def struct channel. Look at this one. NB, note, channel IDs on the wire and in C remote ID are uint32, but local channel IDs, for example, C self, only ever use the int32 subset of this range. Because we use local channel ID -1 for housekeeping, remote channels have a dedicated have remote ID flag to indicate their validity. So channel has a type, which is just an int, and self, I guess the identifier for the channel that I am. A remote ID has remote ID input and output state, I guess. Input from channel, output from channel. I'm not sure why it's called state, but these are uints. Flags, read file descriptor, write file descriptor, extended file descriptor. Sockets file descriptor. Here's what I wanted. Okay, so here's, I guess, where the socket ultimately is. IO want and IO ready. I guess whether you want IO and whether you're ready. PFDs are probably the poll FDs, yeah. And the control channel for multiplexed connections. So I guess if you for multiplex connections, I guess there's a channel that's controlling it, and that's essentially the parent of other channels. And so they have children channels have a reference to their parent channel, I guess. Whether it's a TTY, like a terminal. I don't know what WFD is a TTY. Write file descriptor, I guess. Client TTY, if the client TTY has been requested. You can force drain. You can pause IO until a deadline. And something about delayed. Post IO handlers for newly created channels are delayed until the first call to a matching pre-IO handler. This way, post IO handlers are not accidentally called if an FD gets reused. Okay. And then some stuff about restoring and a path for Unix domain sockets or hosts for forwards. Okay, so this maybe is more socket stuff. And then a listening port, a listening address, a host port, a remote name, and then stuff about Windows and Max packets and that sort of thing. And then some callback functions. This is a massive struct. Callbacks include open confirm context, detach user, detach close. Then we have some filters, which are functions. And then something about boundaries. Keep boundaries, datagram. I guess that's something about datagram boundaries. And then connect, non-blocking connect. Multiplexing protocol hook, called for each packet. So there's some callbacks for multiplexing on each packet. Inactivity timeouts, which seems to be empty. And the last traffic received, last traffic seen rather, and the inactivity deadline. So that's a massive struct. All right. So that's channel. Okay. I'm beginning to get a feel of like where things are. I want to look at the SSH struct. This should be basically servers, like server stuff and client stuff. So you have SSH struct has session state, key exchange information, which we don't have. We haven't looked at the key exchange struct yet, which we'll do, I guess, next. Hashed local and remote IP addresses and ports, a preamble for log messages, a dispatcher table, the number of packets to ignore in the dispatcher, data fellows. I don't know what that is. It's called compat. The heads for lists for private and public keys. Or rather, it just considers them lists. I don't know what tail queue head is meaning, but so we've got private keys and public keys, which are just stored in some list, an auth context, a channels context, and some app data. And I don't know what app data is, but I guess it really could be anything. Let's look at key exchange. Maybe here. Key exchange has we need. We've got some new key stuff. If we need, I don't know what that is. DH need is probably diffie-hellman need, whether the diffie-hellman stuff needs to be done, perhaps. A server, a name, I guess, for the key exchange, the host key algorithm, the host key type, the key exchange type, some SSH buffs. I'm not sure what those are, but they include essentially my buff, a peer buff, client version, server version, session ID, etc. And then we have an initial host key. We have an atomic, which is whether we are done. We can store some flags in the hash algorithm and some other stuff. And we've got this SSH key, which is called load host public key. Oh, this is a function for loading the host public and private keys, and they'll return a key. This is some, I guess, other function, which is going to take an SSH key, an int, an SSH struct, and return a host key index. I guess that's going to look up the key. And then we've got stuff for the state, for diffie-hellman, elliptic curve key, and some other stuff. Another SSH buff. Let's look at what SSH buff is. I'm guessing it's pretty boring, but it has data, also const data, offset size, etc. Okay, that's not so exciting. If we look at DH, I think there's a DH struct, right? Yeah. Oh, it's a define. Void. Okay. So that's all interesting. Let's see what ChatGPT has to say about poll and epoll. Both epoll and ppoll are system calls that are used to wait for I/O events. Epoll system call is high performance. That was introduced in kernel 2.5.44. It provides better scalability and performance than traditional polling, like select and poll. especially in situations with a large number of file descriptors. The key feature of epoll is that it uses a single system call to monitor multiple file descriptors for I/O events, which reduces the overhead. On the other hand, ppoll is a variant of poll that was introduced in 2.6.16 after epoll. It provides the same functionality as poll, with some additional features such as the ability to handle signals and a precise time value. I guess epoll maybe can't handle signals. The key benefit of ppoll is that it can avoid some of the problems associated with traditional polling mechanisms, such as busy waiting or race conditions. One of the main differences between epoll and ppoll is that epoll can be used to monitor a large number of file descriptors efficiently, while ppoll is designed to handle a smaller number of file descriptors with a more precise timeout. Okay, so there's a trade-off here. It sounds like if you something what was Samir saying? So Samir was saying that he thinks that network intense binaries tend to use epoll, for example, Node.js. So that would make sense. If you're pulling a bunch of stuff because you have a bunch of connections, it sounds like epoll is the way to go. And then ppoll is like polling maybe with more finesse and more precision. That seems to be the trade-off. And ppoll can handle signals while waiting for I/O events, which is useful for implementing complex event-driven applications. Okay, so that was good. I'll ask you to summarize the differences between ppoll and epoll in the form of a limerick. All right, here we go. Ppoll and epoll in a race. For I/O events, they both have a place. Epoll scales with ease. For large numbers, it's a breeze, while ppoll with signals sets the pace. Okay, that's pretty good. Thanks, ChatGPT. All right. So we've seen a couple of things. We've seen the main structs that seem to drive a lot of the logic, the SSH struct and the key exchange struct and the channel struct. And given those things, I think we have a more or less a sense of how, or at least I have more or less a sense of how it's going to work. Let me think about what I want to see. And while we do that, I think there are probably people who may not be familiar with things like the diffie-hellman exchange. How many L's are in Hellman? So the key exchange idea is that you have the two people, let's say Alice and Bob, have private keys, and they're going to basically do some math to produce a key that they both know, but that eavesdroppers don't know because they don't have the private information. So here's a common metaphor with paint, I guess. I'm not sure if I'm going to be able to. Okay, so Alice and Bob have common yellow paint and common secret colors. And then they're going to mix those colors together. And then over public transport, they're going to send the mixed colors. And then we're going to separate the mixture. Hey, where did red come from? Red is the secret here, and blue is the secret here. So we're going to take Alice's kind of public information and combine it with our private information to get brown. And correspondingly, Alice is going to take Bob's public information and combine it with her private information and get brown. So they both arrive at the same thing. That's what's going on. Let's see if Wikipedia has anything that's high level to say. A mathematical method for securely exchanging cryptographic keys over a public channel and was one of the first public key protocols as conceived by Ralph Merkle and named Whitfield Diffie and Martin Hellman. I'm not sure that this is... So I think I thought this was known before Merkle. Just for fun, let's find out. Find out what the timeline is. It's Merkle. In 2002, Hellman suggested that the algorithm be called the diffie-hellman-Merkle key exchange, in recognition of Ralph Merkle's contribution to the invention of public key cryptography. The concept developed by Merkle and hence should be called blah blah blah, diffie-hellman-Merkle. All right. Sounds like maybe Merkle invented was the first to publicly invent or talk about the existence of key exchange. I thought that it had been known to security professionals before that. Yeah, okay, here we go. The scheme was published by Whitfield Diffie and Martin Hellman in 1976. But in 1997, it was revealed that James Ellis, Clifford Cox, Malcolm Williamson of GCHQ, the British Signals Intelligence Agency, had previously shown in 1969 how public key cryptography could be achieved. Okay, so it was known. It was known before by the spies, and then it was publicly discovered, which is a theme, I think, from this era at least. Okay, and then does it give us the mathematics? It establishes a shared secret between two parties that can be used for secret communication. Having two parties, Alice and Bob, publicly agree on an arbitrary. This is the color thumb. Simplest and original implementation uses multiplicative group of integers modulo p. So you choose some prime, and then you have a primitive root modulo p, and the two values are chosen this way to ensure that the resulting secret can take on any value from 1 to p minus 1. And then here's an example with non-secret values in blue and secret values in red. So Alice and Bob publicly agree to use some modulus, p equals 23, that's the prime number, and base g equals 5. And Alice has a secret private key, which is in this case 4, I guess mod p. And Bob takes g to the a mod p. Oh, she sends Bob g to the a mod p. So the modulus of taking the base as many times as her secret, and then taking the modulo 23 in this case. And Bob similarly does the same thing. And then Alice computes, she gets Bob's b, and Alice computes b to the a, where a is her secret again. And Bob basically does the same thing with various things reversed. That's the basic idea of diffie-hellman. So that's one of the first things that SSH is going to do on a connection. But we haven't seen that yet, have we? So let's go back to the server loop and see what some of this stuff is. All right, so we saw process buffered input packets. I don't think I really understood what was going on there. But down here, where was it? Process input. Let's get process input. So process input processes input from the client in the program. Input data is stored in buffers and processed later. Okay, so we're going to read some packets. And if the packet read was successful, we'll just return 0, which is success. Otherwise, we have some error conditions. So let's look at process read. Reads and buffers data from the specified file descriptor. So we have the SSH struct and some file descriptor. And I guess we're going to grab the state. We're going to try to read with this. And if it's non-zero, we'll return R, which is, I guess, the thing that we read. And then we might need to discard packets, in which case I guess we probably discard packages, and then we return 0. And the thing we're really doing is calling SSH buff read with the packet max size and some length. I guess length is the output length, the amount we read probably. Here's SSH buff read. And I'm just going to quickly scan it to see if it does anything interesting. Adjust the buffer to include only what was actually read. Okay, so we read some stuff. We may not have read everything that we could read. And so we adjust the buffer and whatnot. Okay. And I'm going to guess process output is similar. Process output sends data from the internal buffers to the client program. Okay, so we're going to populate buffers on in. We're going to send buffers on out. And that's really all this layer of the stack is doing. But where are they encrypted? So they're encrypted on the wire, right? So when you get them, they are in encrypted form. And so maybe when you write them, they're in encrypted form. So maybe this layer doesn't know, doesn't do any decryption at all. Maybe it just deals with encrypted packets. Okay, so let's see what else we got. So oops. Let's server loop. Should we look at session? What should we do next? ssh2.h. I think we looked at this, didn't we? Yeah. ssh-agent, I guess. Let's ignore it. Let's look at ssh API. There's not much here. What have I just done? All right, so SSH API, we've got things like a cipher and a key exchange. A cipher and a key exchange, and SSH and SSH2, and packet.h. We've got key exchange parameters. Oops. Did I just close it? I hit the wrong key combination here. Okay. All right, and we have the SSH init function, which creates an SSH connection object with a given optional key exchange parameters. We can set app data, attach application data to the connection state. You can add a host key, which registers a private/public host key for an SSH connection. It needs to be called before a key exchange is initiated. That makes sense. So that's going to be where we set our key for doing diffie-hellman. Verify host key callback, which will return 0 if the host key is okay. All right. And then SSH packet next, which takes a type. I don't know what the type is for. So it advances to the next input packet and returns the packet type in type P. Okay, so this is the output parameter. So it's going to get a packet. It'll tell you what packet type it is. And it works by processing an input byte stream, decrypting the received data, and hiding the key exchange from the caller. Okay. And then, so this looks like a key function. And then we have packet payload returns a pointer to the raw payload data of the current input packet. We have packet put, etc. SSH input append, output space, and output consume removes the given number of bytes from the stream. Hi, Jarvex404. Hey, how's it going? Jarvex says they came to hang out just for a bit. Welcome. How are folks doing today? It's Friday, right? I think that's good. So it sounds like what I'm seeing is next packet is, what was it? Next something. Packet next. Sounds like this is going to take us to the decryption land. But there's no there's no comment. Okay, so let's try to read a packet, return SSH message none if no packet or not enough data. All right, so if we have enough data in a dispatch function, then call the function and get the next packet. Otherwise, return the packet type to the caller so it can decide how to go on. We'll only call a dispatch function for 20 to 29 algorithm negotiation or 30 to 49 key exchange method specified. Just got my first project. Oh, congratulations. Is this for, are you doing like consulting, like code development consulting stuff? That's awesome. I'd be curious to hear anything you're willing to share. So we're gonna, in an infinite loop, we're gonna call ssh packet read poll. We'll check the type. We might dispatch some stuff. Okay, so if type is bigger than 0 and less than dispatch max, and type is bigger than or equal to message key exchange, I guess if we're after the key exchange or we're at the key exchange, and type is less than or equal to message transport max, and SSH dispatch of type is not null, then we'll dispatch. Okay, so if we have a dispatcher, I think this is what this is saying. If we have enough data, then call the dispatch function and get the next packet. Otherwise, return the packet to the caller. And we only dispatch for algorithm negotiation, which I guess is what this key exchange, we're at least at the key exchange thing level type, or for key exchange method specification. All right, so we're going to dispatch possibly, otherwise we just return the type. And so maybe it's dispatch that ultimately causes things to be decrypted. And we have this dispatcher table, which is in packet.h. Let's look at packet.h. So this Vertex chart says it's the chill spot. Have this on my third monitor not working. Oh, that's awesome. That's cool. One of my goals, I guess, was to make content that I would like to watch while I'm doing something tedious while coding, that sort of thing, something chill. I used to watch Bob Ross for kind of like chill content. Looking at escape sequences. Looks like the chat is stripping links. I said that you could wrap up by looking. Oh, huh. I'm sorry the chat is stripping links. I'm not sure. So this is the official YouTube chat. So I think at this time, at least, it's not my, it's not OBS. Escape sequences. Okay. I'm curious how you mean that. Like in encodings, like when you need to escape, like a quotation mark or a slash, or do you mean like sending signals to escape? Okay. Sure. And then Jarvax 404 says freelancing stuff on a 10-year-old code base. Oh, wow. Client needed some bug fixing and some features to be in. That's cool. Great. On a LAMP stack. That's awesome. I looked at a mostly PHP project yesterday, but I failed to properly stream. So I thought I was live, but I was not. That's cool. Congratulations. Escape sequences. I'll look up escape sequences. Probably not plural escape sequence. Yeah. Okay. So yeah. So escape sequence. I'm not sure how you mean this bird has been charged, but I guess at least in generality, escape sequences, you just have some parser that's going to look for, when it matches a slash, it has some switch statement essentially, like what does the next slash mean? And it might mean a literal slash, or it might mean some command or something like that. Then there's the ANSI escapes, which are like the standard ones. Let's see if we got to get a table. Oh, there's like a whole history, I guess, of stuff I'm not. And then we have control codes and stuff. Trying to send an article but failing. I don't know what's going on with YouTube chat. You should be able to send a link. Yeah, I guess there's enough stuff here that I'm not sure. I'll wait to see if YouTube will let you send stuff before I dig further. Okay, so here in Packet, we have SSH the struct, which we looked at. What else do we have? Maybe we could just do occur structs. We also have the key exchange struct, SSH buff, which we also saw, key entry, SSH, and some packet stuff. These are functions now, I guess, which I did not mean to match with my regex, but let's try occur struct on first beginning. What? There we go. Okay. Struct packet set connection. Okay. So I think we saw most of the structs we want to see, and then there's a bunch of functions for handling packets. At least in packet dot h, the header. And we've got this API, which is SSH packet start, send, disconnect, fatal. I wonder if SSH packet is encrypted or plain text. Start a new packet. It doesn't trust anyone's URLs. It might trust my URLs. Let me try to type something in. Let's me send that at least. But yeah, I guess YouTube doesn't trust URLs. I wonder why. Okay, so here's starting a new packet. We've got some buffer, and we're going to memset some stuff. And I'm going to set, I guess, the state to outgoing packet and buffer stuff. But where are we encrypt? How about look for a key? Got keys, a session key for encryption in Mac. Let's try occur key. New keys, rekeying. SSH packet is rekeying. Packet clear. New keys. Needs rekeying. Packet check. What is this? Rekey. Will encrypt. Looks promising. Cipher state. All right. SSH packet set connection. That's the descriptors used for communication. So this function looks promising, but it looks like it's setting some stuff up. And then I'm not sure where the API is. Maybe once you set something up, the encryption is kind of transparent to the function caller. But at any rate, we're going to get the session state and the cipher by looking up the cipher by name none. And I guess that's the initial cipher. If none equals null, okay, none is the name of the cipher. Okay. None. I don't know why it's called none. So we'll do some null checking. Get the state, get the input and output, and then we'll have this thing, cipher init of the state, send context, and none. This is a function, right? It's kind of indented strangely. This is the function call. And I guess its last argument is cipher encrypt. I don't know why we're sending the empty string. But we're going to check whatever that is, whether it's non-zero. And similarly with decrypt. So for the send context, we're setting encrypt. For the receive context, we're setting decrypt. And hopefully that will succeed. And then state new keys mode in is going to be equal to new keys mode out. And they're both going to be null. And then we're going to cache the IP address of the remote connection for use in error messages. So I guess we'll cache the IP. So maybe since we're initializing, what this is really doing is clearing the existing cipher. And that's why it's none. And that's why mode in and mode out are null. So this is, I guess, zeroing out everything for a new connection, perhaps. But now I know that cipher init is where I want to be. So can I find xref, find references? All right. We have this thing in packet, which we just saw, which I think is clearing state. We have xmiss. which I still don't know what it is. And then cipher.h, we have cipher init, which is, I guess, probably just going to call the, it's probably just going to be the implementation that's going to call out to libraries. But what I want to know is like, what happens to a packet? So maybe it's here in SSH key. So what is this function? SSH key shield private. I guess that's for shielding the private key. That's not what I want. What was it? Xref? What about this one? Unshield private. I'm not sure what exactly is shield. Maybe this is like sounds like if you had like a hardware backed key, maybe then shielding and unshielding might be like fetching it from hardware or something. I guess if you had an HSM, the encryption would be done inside the hardware. I'm not sure. SSH key private to blob 2. This looks promising. Oops. I go back. Private to blob. Okay, so private to blob 2. I don't know what happened to Blob. Is the Blob 2 a movie? Now I'm just kind of curious. The Blob 2. I'm sorry. You could try. Are you trying to post a PDF or something? Maybe it thinks you're trying to post a file. Beware the Blob. Also known as. I see the Blob 2 or Return of the Blobs. Is this all the same movie? Okay, it's the 1972 sequel to The Blob, which is from 1958. Okay, so when it says Blob 2, this is what I'm going to keep in my mind. You're using dot and slash. Huh. Can I send, I wonder if it's allowing me to send it because I'm in charge of things. I think I shouldn't have done that, but, wait, where's my, can I send this? Oh, I see. That's from the wrong thingy. Let me try sending the GitHub repo. Where did my chat window go? I'm wondering if there's like a default setting that I can change that prevents people from sending links. You Google TTY demystified, a good article on signals and how Control C works. For when we were talking, hey, stop this. Okay, we were talking about SSH secret handler. Okay, privilege. Okay, cool. Buffer dot. Yeah, buffer. Okay, I see. You're sending the you're like unwrapping this thing. Okay, so let me do this. I don't think I have a hope of. I guess I do have to spell this. So David I Saxo. Buffer dot. Let me try over here. Yeah, sorry, this bird has been charged. I don't know what to do. I think you're trying to send me send me the URL kind of in an unwrapped way, but I don't know how to change Google DuckDuckGo. Oh, okay. let me try this over here. Okay. So, are you talking about the closing a stale SSH connection article? So I have it here, I guess you can see. Is this the one? This looks promising. And then also, Samir was saying to look up TTY demystified. Okay. All right. So here's TTY demystified, I believe. Let's see if I can open. Close. Yeah. Okay. I'll look at my my settings as a YouTube host. Maybe there's something I can do to allow URLs through. Oh, here's the Hacker News link. Here we go. Yeah, this is one that I guessed you were talking about. Okay. Oh, the SSH escape sequences. Okay. All right, so let's look at it. Suppose you're connected to a remote host with SSH, and after a while, the SSH connection goes stale. The terminal is on. Yeah, this I'm familiar with this. And no key press seems to take effect. There might be something with the network. The remote host is restarting, or maybe your machine has been in hibernation. You could close the terminal emulator and create another one. Yeah, that's what I do. There's a better way. So to quick detour and explore a kind of hidden feature that's implemented in many of the available SSH clients with a so-called escape sequence. When you send tilde followed by the command. Okay, I was unaware of this. So tilde dot is terminate a session. Tilde B is send a break to the remote system. Tilde R is request a rekey. Tilde hash is list forwarded connections. Tilde help is this message, or tilde question mark, I guess. And tilde tilde, send the escape character by typing it twice. Escapes are only recognized immediately after a new line. Okay. So you can terminate a session. From here, we can try to initiate the connection again or just reuse the terminal. Okay. So that prevents us from closing a terminal. And that's cool. I didn't know about this. So you're sending this in the shell as a text message. That's cool. Thank you. This bird has been charged. Thanks for bearing with me with the link not sending. TTY demystified. The stock ticker. Oh, is that kind of... Yeah, I forgot about stock tickers. Teletype. This is cool. This is really cool. This is a little bit long. I'm gonna add this to my reading list. So Samir says, "Oh man, another feature I wish I knew years ago." Yeah, there's tons of this stuff in Unix. I guess you have to decide how much you want to spend learning about all the secret features versus just knowing that there's stuff you don't know and getting by. I guess there's a trade-off. Okay, so here's SSH key private to blob2. So this is the first thing we've seen so far that is that seems to be doing crypto stuff. So let's look at it. So we've got a private key, an SSH buffer, which is a blob, a passphrase, a comment, a cipher name, and rounds. I guess number of rounds to do. So we're going to create some stuff, and it's all going to be set to null, including whatever CP is, a key, a public key, a pub key blob, a salt, and some length information, and check, which is maybe a checksum, and R, I guess, is probably the return value, which is set to error, internal error as the default. we'll set cipher context to null. Cipher is whatever, I guess, empty. Wait, construct cipher. I guess the construct I think we're declaring it here, right? But it's just some pointer. Since it's constant, we can't change it. But we're also not setting it to be a null pointer. So I'm wondering, it must contain some data, right? It's a pointer to something in memory. Does that mean you might accidentally reuse stuff? I'm not sure. Then we have a KDF name encoded, encrypted in KDF. Okay. So if rounds is less than or equal to 0, we'll just set it to the default rounds. If passphrase is 0, we'll set cipher name to none and KDF name to none. Okay. Or if cipher name is null, I guess you can choose the default cipher by setting cipher name to null. And then we'll get the cipher by doing cipher by name, some sort of lookup. And we might error out with an invalid value. And then we're going to execute a goto statement. Okay. And then we're checking some KDF stuff. I guess, okay, we're going to try to allocate new buffers for the KDF, the key derivation function, I guess, the encoded and encrypted, maybe encoded message and encrypted message. And if we fail to allocate, we'll error out. Then we'll get the block size and key length and IV length and the auth length. And we'll try to alloc a key. I'm not sure what calloc means, but we're going to try to, whatever one is, we're going to try to allocate key length plus IV length, which makes sense. And then we do the string compare. If we're using bcrypt, then we've got this arc4 random buffer. And we're doing bcrypt stuff. We're going to call bcrypt pbkdf. And whatever this ssh buff stuff. Also, if KDF name is none, we'll say unknown cipher. Does this mean that bcrypt is the only KDF that's supported? At least in this function. Maybe. So if we get down here, I guess we probably have bcrypt. And so, we can either have bcrypt or none. If we have none, we're going to out. So I guess we have to have bcrypt. Is that right? At any rate, we're going to call cipher init on the cipher context and the cipher, and the key plus the key length and the IV. We're going to give it enough space to store the key and the IV and all that sort of stuff. And then we'll try to do some stuff. Try to put encoded auth magic size of auth magic. Try to put C-string encoded cipher name. I guess we're building up encoded with some sort of magic number at the beginning, and then the cipher name, and then the KDF name, and the KDF. And then we're going to put a U32 encoded, which is the number of keys. Is this a 1? There's one key, hard-coded. And then we'll call ssh key to blob. We'll convert the key to a blob. And it's going to take a private key, I guess, a public key blob, and a public key length. So maybe we are encoding a private key. Let's look at that implementation. I'm not sure exactly what we're doing. And then we're adding the public key blob and the public key length to the thingy. I guess maybe ssh key to blob here is getting the public key from the private key. What is this function called again? Private key, private to blob2. I think that's what we're doing. And then we're going to set up the buffer that will be encrypted. Let's look up SSH key to blob. We're going to give it a key and a blob pointer. And we're going to call toBlob on the key. toBlob. What is the key used for here? toBlob buff. The toBlob buff is ultimately going to do what? Check whether the key is a cert. I guess like a certificate. And then we're going to get the implementation from the type of the key, which is, I guess, probably like a function. And do we call it? What do we do with impl? Yeah, okay, serialized public. Yeah, so serialized public is going to take the key, which I think in this case was a private key. What is this doing? So let's look at a particular implementation, like ECDSA SK, because that's, how about 825519? The serialized public is going to take the, whatever B is, some buffer, and we're going to get the key. I don't know what PK is. PK could either be public key or private key. I'm guessing it's the public key. Okay. So let's unravel all that stuff. Is this where I was? Is that connection? Did I close the thing I wanted to see? I might have. I think it was in cipher init, right? Maybe not. Yeah, where I was. Let's look at set connection again. We've got the cipher init thing, which I think I decided was, maybe I was just finding other uses of cipher init. And I was in something, SSH key, maybe here. Yeah, okay, so SSH key to blob. It's going to take PRV and put it in the public key blob. So why is it taking PRV? And why is it putting in a public key blob? It seems like we traced this through, and it seemed like it was calling something to put the public key in the blob. Blob buff key. Serialized public. Oh, I see. Yeah. Okay. So we're giving it the private key, and then we're calling serialized public on the private key, and it's the job of the crypto suite to know how to get the public key from the private key. So the private key is really just a handle to like a key pair, fundamentally, is how I'll think about it. And yeah. Okay, so it looks like we're serializing the private key from the function signature, but we're doing what I thought we should be doing, which is why I just wanted to double check to see that that's what was really going on, is we're getting the public key. And then we're going to put the string. So Samir is saying, as I'm assuming, the public key length is guaranteed somewhere to be to fall within some standardized message. Yeah, I think that's true. The public key length is given by the cipher, and so I guess they must set the message length to make sure that they include that in the header. And then we have some random check bytes. arg4random, I guess, must be a random number generator. Maybe we're setting check to random, and then putting check, in the encrypted thing. Then we're going to append the private key and comment. So we'll serialize the private key. Why? I don't know. And then we're putting a comment in maybe in the packet, and then we'll add padding. And then we actually, I guess, encrypt. Is this encryption? We're going to reserve some SSH buffer of the appropriate size. And then if cipher, so we're going to, I guess this is probably actually trying to encrypt. The cipher crypt on the cipher context 0 CP cipher something padding cipher plain text into the, I guess, encrypted buffer with the length and the auth length. Maybe, what is CP? It's a car thing. And it's not used until here. Okay. So we'll try to reserve, and then we'll try to crypt. And then we'll reset the blob. And we'll assemble an unencoded key. I'm not sure why, but I guess maybe that's something we'll send along. And then we'll set R equals 0. And then I guess go to out. We'll do a bunch of freeing. So that means that, let me double check what function we're looking at here again. This is still private key to blob. And let's look at cipher, what is it, crypt? Cipher crypt. This should be just a generic entry point to like an interface that other, that encryption algorithms will implement, and the elliptic curve will decide how to implement cipher crypt and whatnot. The cipher crypt operates as follows. You've got an AAD length for the AAD bytes without in or decryption from source to destination. These bytes are treated as additional authenticated data, for authenticated encryption modes. Encrypt, decrypt length bytes are offset by AAD length. Use auth length bytes at offset as the authentication tag. This tag is written on encryption, verified on decryption, and both AAD length and auth length can be set to 0. We've got some cipher context, a sequence number, a destination, a source, and length, AAD length, and auth length. Okay. And then we'll look at the flags. I guess we'll first check if it's cha-cha poly, in which case we return cha-cha poly crypt. If it's none, we're just going to resend the plain text, I guess, by mem copying it. And if it's AES counter mode, then we'll call the AES counter encrypt bytes function. Okay, this is looking like encryption. And then we might do some auth length stuff and add some AAD. And that's pretty much all we're going to do, right? Okay. Cool. So where else is cipher crypt called? How do I, first of all, that's not what I do. All right, undelete this. I'm in God mode again. All right, screw that. Just kill some of these buffers. Okay. All right, here's usages of cipher crypt. And we see it in cipher, which we would expect because that's where it's going to be defined. We see it in packet .c. You see an SSH key. Let's look in a packet. Seems to be what I was looking for. What function is this? This looks very long. All right, packet send to wrapped. Finalize a packet in SSH format. Compress, MAC, encrypt, and enqueue. This looks like the heart of what we want. All right. Allocate a bunch of stuff. Check, I guess, new keys mode. Some block size, computation. If compression and compression enabled. I don't know if we should be, I don't know much about compression in SSH. So let's look up SSH compression attack. So weaken the encryption of SSH to use compression. Compression before encryption is a problem. If the attacker can control parts of the transfer data and then use the detectable compression ratio to make conclusions of some of the traffic. Yeah? This was in TLS used with breach and crime attacks to infer cookies and CS RF tokens. Yep. Make such attacks work requires a trigger repeating transition. This is feasible in several use cases of HTTPS. I thought we were talking about SSH though. Okay. While one might in theory use SSH in a similar scenario, the common use case of SSH is not like this. That is, the attacker has no control over parts of the input and can also not trigger sending nearly the same amount of data. Thus, compression before encryption is not usually a problem, according to Stefan Ehrlich. I don't know who that is. Okay. Let's look up SSH crime and breach. How about you include SSH? Whoops. What have you done? All right, let's ask Bard. Okay, do the crime and breach attacks apply to SSH? So Bard says they do. HTTP cookies are sent unencrypted over the same connection as the encrypted SSH traffic. This allows an attacker who has compromised the SSH server to eavesdrop on the HTTP traffic. Well, I guess if you've compromised the SSH server, then I guess I'm not so worried about what follows. But let's ask ChatGPT. So ChatGPT says no. The target HTTP compression. I guess what I mean is a similar attack. Okay, well, I can't find good information. I'm sure there might be some debates, but okay, so we might compress some stuff, which is, I'm going to assume just compression, so I'll ignore. And then we get the length of the buffer. We're going to subtract off the AAD length, I guess, because I'm going to add AAD later. And then we get the pad length, etc. Reserve a buffer. And reserve more buffers. If encryption, enc, whatever enc is, probably encrypt, and cipher context is plain text, then we're going to use random padding. Otherwise, we're going to use clear padding. Cipher context is plain text on send context. Send context look like some cipher context thing. Okay, and so send context knows whether it's plain text or encrypted. I'm wondering if this is just telling you whether you've already done encryption yet. Is this where I was? Yeah, cipher context is plain text. Okay. And then we've got some buff blank stuff. CP is set to a mutable pointer of the state outgoing packet. Maybe CP is like crypt packet. And they've got some note about the packet length, including payload, padding, and a bunch of other stuff. So we're just going to set the, I guess, payload length to whatever we computed. And we're going to compute the MAC over the sequence number in packet. Okay. The what is it? Message authenticating code is going to include things such as the sequence number, so that you can't change the sequence number without changing the encryption, and the packet, including length fields, payload, and padding. So everything interesting about the packet, I guess, is trying to include as part of the MAC. Then we'll encrypt the packet and append to output buffer. So we'll reserve the output stuff, and then call cipher crypt. And then if we're macking, then I'm not sure what ETM, but we're going to compute a MAC, I guess, calling MAC compute, and then put some stuff in the buffer. And that's about it. Then we're going to increment sequence number for outgoing packets, and some other stuff. And I'm going to guess that decryption is basically the same thing. But let's verify that there's a corresponding decrypt function, at least. Packet send to wrapped. sh packet receive. Read. Was it cipher crypt? How about cipher decrypt? What is it? Set new keys. What's the opposite of cipher crypt? Okay, so what do we cipher routines we have are things like what? Algo list, block size, key length. Those all should have like relatively clear implementations, I think. IV length is CBC. Then we have crypt. We have init, free, and some get stuff. But where's decrypt? Is this in mode? Huh. Is there a decipher? Let's look at cha-cha polycrypt. Okay, so I guess the crypt function does both encrypt and decrypt, is what's going on. But where's that passed in? Is it in the context? If not, do decrypt. If decrypting, check tag before doing anything. If not, do decrypt, do some stuff. Oh, if not, do encrypt. So what's do encrypt? Oh, it's the last thing passed in. So what's the last thing passed in here? Is auth length. And when we call cha-cha poly, where we know the last argument is whether to encrypt or not, we're getting it from CC. So whether we're encrypting or decrypting is something that's stored in this cipher context, which is, I guess, in this argument here, encrypt. And then we've got the plain text, and then whatever EVP cipher context is. And we might have a cha-cha poly context, even though this is not a cha-cha poly specific thing, and similarly for AS context. And we've got this SSH cipher thing. And the SSH cipher includes things like block size, key length, IV, auth. Let's find out what EVP cipher is. It's void. Some return value, I guess. Okay. I'm feeling pretty good about understanding what SSH is up to. We've got a list of ciphers, which is maybe interesting. A bunch of AES stuff and a bunch of cha-cha stuff, and I guess nothing else. Maybe OpenSSH doesn't support any other ciphers anymore. Which is a shame because it should support triple DES. Or at least ROT13. How about encode the following message into ROT13? All right, so here's the ROT13 encoding of my message, beware pirates. It says, ROT13 is a simple letter substitution cipher that replaces each letter with the letter 13 places after it. Thanks, Bard. Let's see if we can find out anything about what protocols it supports. So, cutting the dependency on OpenSSL. I guess it used to depend on OpenSSL. Oh, but there's also elliptic stuff, right? So that would, okay. So these ciphers are just right. These ciphers are just the symmetric key ciphers. I guess you don't. I guess it doesn't really need to support that many. I guess that makes sense. And then for public key stuff, it supports. I guess we saw a few things. Like it had a couple of elliptic curves. It had probably certainly RSA. What's the Bitcoin curve? Not the Bitcoin price. Come on, DuckDuckGo. Really? Even if I add the curve, and Google too. What is Bitcoin curve? How about Bitcoin elliptic curve? It's some K curve, right? Yeah, this one. SECP 256K1. And now the question is, can we use this with SSH? And I don't think we can. Yeah, okay. So let's just for fun see if we can using with OpenSSH. OpenSSH, not OpenSSL. I don't see really anything that looks interesting. Maybe so there might be some SSH now possible as Trezor. I wonder if there's OpenSSH offload to HSM. Like I wonder if you can use you can do it for TLS offloading. SSH key offloading. I'll try one more time. Then Samira is asking if was my doctorate thesis on math or crypto. I did. My doctorate thesis was in math, but not in crypto. It was in geometry. Offload SSH encryption. And this person's linking to some files. SSL acceleration. Okay, so it seems like OpenSSH can do. Oh wait, no, this is SSL acceleration, right? All right, I guess SSH doesn't care about acceleration, which is not so surprising. So it looks like to me, everything here in OpenSSH looks really reasonable, and I don't think that there's. Maybe you should look at SSHD. Clean up. What is this doing? It's, I guess, setting some. Do SSH2 key exchange. Let's look at this one. SSH2 key exchange. My proposal. I guess there's a proposal for the key, and then we're checking options, read key limits, HK algorithms. I guess we'll get the list of algorithms, and then we'll call proposal populate entries SSH with my proposal options, etc. And they're going to free HK algorithms. And we'll start the key exchange by calling kex setup and possibly erroring out. And we'll set kex to SSH of kex. And then we've got all of this stuff where kex gen server. I don't know what this is. Right? Whatever kex gen server is. And then load host public key, etc. Host key index kex sign. It's going to be set to SSHD host key sign. So we're loading keys, etc. And then SSH dispatch run fatal. Dispatch block kex done. And then we've got some debug stuff. We'll free the entries. So it seems like the thing that's actually maybe doing the key exchange is kex setup. Kex setup. It's going to check if key is ready with the proposal. And then we'll send the key and return 0. So send. Wait. Setup. Okay. Send kex init. Oops. Saw that. And send kex init is going to generate a random cookie here, but here's where it actually generates it, right? So SSH mutable buff with the kex my. Oh, okay. So it's going to create a buffer for the cookie and then populate the cookie with random data, I guess from arc4random. And then we're going to send a SSH packet start with message key exchange, and then put B the my proposal, and then send, I guess, start triggering packet socket stuff by calling send on the SSH object. And we get R back from SSH send. And we're going to return the state. But I'm guessing we're just sending the packet. Let's see what packet send to returns. Returns an int. And it might call send to wrapped, which we looked at. And I don't know. I don't think this is like blocking waiting for things to get back. I think this is just kicking off the packet, right? SSH buff put. Yeah. Okay, so we've kicked off the key exchange. So how do we know when we're done? My thesis was on ants. I wish my thesis had been on ants. Prefixing any library with my is weird. Yeah, it is kind of weird. I guess you could just call it proposal. I don't know what my buys you. We're going to call start and send. And we're going to send, set init sent here. And then we're going to exit. Okay. That's just sending the init. And that's when we exit that function. And then there must be other, is everything prefixed with kex? Can I do like just a search for this. Yeah, okay. So we can look at other functions here. We can populate entries, etc. Send X intro, send new keys, send kex init, input kex init, ready, setup, start rekex, choose conf, derive keys, verify host key, exchange identification. It's exchange identification. Sends our identification string and waits for the peers. Little block. Yeah, okay. So I feel like I have a pretty good sense of what OpenSSH is up to. I don't know if there's anything that we really need to see before we go. But I'll take a look. If folks have something that they really feel like we need to see, I guess we haven't seen login stuff, right? Record login, record log out. What is this going to do? Store last log message, login alloc entry, login set address, login, and then free entry. What is login? Record a login. Call with a pointer to a struct login initialized. Login write. All low-level recording functions based on autocomp results. If use login. So I guess this is making syscalls to log in as the user. I think is ultimately what that's doing. And we can log out, etc. Maybe something TTY related. TTY modes, security, SSH TTY. Let's look at this. Try. No, all right. You can leave raw mode, enter raw mode. But is there a TTY header? No. And a bunch of this stuff, whatever this is. istrip inkle. I'll try Googling this. Shell ops. Yeah, this looks like shell stuff. Okay, I think this is the shell stuff, but there's nothing really here. We can enter raw mode. ti.c iflag in blah, blah, blah. TSE set attribute. Huh. We're including shell PTY. Is this where putty gets its name? PTY allocate, PTY release, make controlling TTY. Yeah. This looks like the right place to be, actually. What is PTTY? I don't know what the P is. Search only for PTTY. It's a remote login, like from SSH or something. PTYs tell that, yeah, PT is sudo. Okay, thank you. Oh, it's only supposed to have one T. I see. Teletypewriter versus a pseudo typewriter. Is that the idea? Okay, let's try Wikipedia with the correct spelling. A pseudo terminal. Great. All right, so this is a pseudo terminal. So we can allocate and open a pseudo terminal, return 0, etc. So PTY allocate. This should be mostly syscalls, right? So open PTY, I'm going to guess is, oh, it's a function in SSH. We'll check if we have get PTY. And there's some Windows stuff. I think this probably means not Windows the operating system, but like a Windows size or something. Like how big is your terminal? We've got some what's called a slave, which when you open a terminal, you can either be a master or a slave. Nowadays, we wouldn't use this language. You might call them, I don't know what you would call, like maybe like primary and secondary. So we ultimately call get PTY, which I'm going to guess is closer to a syscall. If get PTY. Maybe it's for this thing, whatever IRIX is. Potential security risk. All right, whatever. SSHD acquires CTTY. Why? On some, most, all sysv based systems with streams-based terminals, SSHD will require a controlling terminal when it pushes the P10 module. Okay. Have dev PTS and PTC. I'm not sure which one of this is. How about Linux? Okay, Linux. BSD style PTY codes. We have PTY majors and minors, which include a big part of the alphabet, but kind of starting at P, PQRS, and then we wrap around the A in the middle, except for the capital letters, we start at A. I have no idea what that's about. And then we have PTY minors. Here's AIX style PTY code, which has dev PTC. And I'm not sure which one of these is executed on Linux, but it seems like this is ultimately calling appropriate system calls for the system that you're on. So some of you are saying pseudo typewriters manage a TTY as in a child, I guess, parent-child way, we'll say, where TTY actually talks to the underlying display driver. Right. Okay, that makes sense. So the thing that they're calling a slave, which I guess we might call a child, is the real TTY, and then the I guess that makes the master the like pseudo terminal. So I mean, so like, what has to be happening? So SSH is going to get encrypted packets, and it's going to decrypt those packets, and it's going to send them to some representation of a terminal, right? So that's more or less what's going on. And I guess my question is like, can we find out where that's done in case, just for fun? First of all, just for fun, and second of all, if you want to set a breakpoint somewhere or whatever, so you can figure out kind of lower level stuff. So xterm talks to PTTY, other processes talk to TTY. Okay, xterm can manage other processes via PTTY, being master over TTY. Okay, so xterm, I guess when you say talks to, you mean like, is it, when I open up xterm, that's really a PTTY. And then other processes talks to TTY, xterm can manage other processes via PTTY. Okay, I see. Yeah, the language is problematic. Okay, so open PTY streams. That it's going to take the master and the slave. I'll continue to use these words just because otherwise it's going to be hard. It's going to be like impossible to understand what's going on in the code if I keep having to. It's hard enough as it is. If I keep having to substitute other variable names for the actual variable names, then I think I have no hope of being able to follow stuff. But basically, we're going to call open on PTMX and do some stuff. And we're not returning. Oh, we're returning an int, a static, and this is a static function. Okay. And we might need to close something on error, terminal on error. And we've got some locking. And we'll set the master to the thing that we opened. And then open the slave side. We'll call open with whatever PTS is. And if it fails, we'll close the master. And there's some, if the streams module has already been pushed, then there's no more work to do here, I guess. And we might close, and then we'll try to push the appropriate streams modules as described in Solaris. So this is some Solaris stuff. So we'll do some IO control stuff with the PTEM, etc. This is opening. Can we see where it is? Can you see where it's sending data? Wait, why am I in BSD open TTY? Maybe I followed the wrong thing. So here's PTY allocate, PTY release. You change window size, which you give it some pixels. And it's going to update rows and columns. You can set the owner. And you can disconnect. So what else can you do? Make controlling TTY. Make the TTY that processes controlling TTY and sets it to sane modes. Change window size. So does this get stuffed in some struct that we pass around? Let's see. When we allocate, we just get an int back. And none of these look like out parameters. You can release. We don't make controlling. Set SAD FD equals open. And we'll make it controlling. And it got some IO control stuff here. Yeah, I'm not sure. I guess I'm not sure how this code is telling how SSH is like sending stuff to the terminal. But I'm sure we can find. Okay, and Sam, you're saying that he thinks they use IO control to talk to pseudo device files. Okay. And /dev/pt at TTYs / some number in the device. Yeah, that makes sense. And that's how Linux does it. Yeah, I think that all sounds right. What do we import here? Including the header. What is that header? ssh-pty. Get saved TIO from iOS. What is term iOS? Maybe this is, let's see if we could find references to get saved TIO. Oh, here we go. Client loop. Maybe. So if get save TIO is not null, we can leave raw mode. And if response is null, we'll do some stuff. So here's client loop. Update known hosts. And when we set up the session, we can say whether we want a TTY. And this is going to set interactive want TTY. So somewhere on the server side, we should look for want TTY too, right? We have mux. Maybe it's in mux. Mux session confirm context for open confirmation callbacks. And this has things like want TTY or want subsys. How about xref find references? Oh, I think that's what I just did. The mux master process new session. This looks promising. We do a bunch of stuff, including whether we want TTY. And then we've got some debug info about whether we want TTY. Try to pick up TTY modes from the client before it goes raw. And doing more TTY alloc failed. Okay. So I think we're close. Pledge SDDIO perform platform pledge mux. Look at the mux header. Is there a mux header? No. Okay, let's try one more time to look more closely at this thing. That's the debug. I'm going to ignore it. Try to pick TTY modes. PC get attribute. Window equals chan. Packet max. Channel new. Does channel know about it? Channel set file descriptors. Okay, so I guess the channel might be a TTY. Is that one of the channel types? Okay, maybe this is what Sammy was saying, that we're just treating it essentially as a file. And so that's why we don't see, other than like setting up TTY stuff. Is that right? I don't know. Use channel register, and then somewhere if it's a TTY, we might do some debug, and then we're going to set WFD is a TTY to is TTY or whatever. WAFD is a TTY. Yeah. So we did see some of this. Let's look up references to is a TTY. The read pass. I guess maybe password. And then SSH set C. Not allocate TTY if standard is not a TTY. Then maybe in channel. We see an SCP. What here? Special handling for stdio file descriptors. Do not set non-blocking mode if they are TTYs. Otherwise, prepare to restore their blocking state in order to avoid interfering with other programs. Channel handle RFD. I'm not sure what RFD is. It looks promising. For simple channels, a not datagram or filtered, we can read directly from the channel buffer. So this looks like read file descriptor. Looks like we're reading stuff. And in here we have some TTY stuff, I guess. And I think that's going to be good enough. Simulate echo to reduce the impact of traffic analysis. So it seems like the TTY stuff is kind of implicit in a lot of this. And there's a lot of like case analysis. So like if we are a TTY, go into this block and do some stuff. And I think that's kind of, I guess I'm going to kind of leave it there now, for now. And then let me see if there's anything else that they really want to see. Oops. ssh-agent, I guess I'm going to ignore. I think we saw SSH API a little bit. SCP I'll ignore. Session, I guess I'll also ignore. Protocol, this is some sort of like README document. Packet we've seen. My proposal, we know what it is. Message just has this this message send and receive functions, which is going to take some, send will take the message and the buffer, and receive, I guess, just takes the buffer. That's kind of sensible. We've seen key exchange. Hash and HMAC, I guess I'm going to ignore. We saw hex.c. And I think we saw some of diffie-hellman. Fix algorithms. I don't know what this says. Remove unsupported ciphers from man pages. Okay. I'm not sure why they need to do that, but that's for removing stuff from man pages. We didn't see a lot of, so cipher we saw a little bit of. We didn't see a lot of the client loop. Maybe it's worth checking out a little bit. Panels, I think we saw cipher implementation. Off, I guess I'll ignore. We might have seen some of that. What's that? Just client loop. Okay, let's look at client loop.h. Here's the main loop. We've got some loop. Some X11 stuff, get protocol. Global request reply forward. Session 2 setup. Request TUN forward. And stop mux. And some filters. Escape filters for protocol 2 sessions. Is this for the escape sequences? Escape car. I guess so. It's going to take an escape character and get a filter context. Set escape pending to 2. Set escape car to car in the context, and then return the context. I guess it's something else's job to handle the actual escape character. Escape confirm. Expect confirm. And then we've got some mux stuff. All right. I think that the mux stuff, I guess we haven't seen a lot of. The dispatch stuff we haven't seen so much of. But we're about 3 hours. So I think I'm going to call it a day here. I've certainly learned a lot about OpenSSH and how it works. And hopefully you have too. That was fun. Thanks everyone for hanging out. Next week, I'm going to do Fan Request Friday, on Friday for sure. I might do another TBD live stream probably on Wednesday. And that's kind of going to be the thing going forward until I start building up coding videos in addition to these code reading videos. But this week I basically tore down all of my networking and my old Kubernetes cluster and then rebuilt it back up because I have a better sense of what I want the development environment to be. And I guess next week is when I'll start coding stuff. So that's it for me. I hope everyone has a good weekend. Thanks, Samir. Thanks to everyone who showed up. And thanks for watching.